Hi everyone, welcome back. So today we're going to be taking some notes and learning a little bit about ionic bonding. Set up these notes on page 26 if you haven't already. The template for these notes, so you can see the important words, are on our Canvas page like usual. So the title's Ionic Bonds. We're going to be learning about how ionic compounds are held together today. Our essential question is, how do we talk about and draw ionic bonds? All right, so here's a little bit of review from what we did before break. I know that was a long time ago, so quick recap. We talked about these things called dot diagrams before we went on break. And these dot diagrams, remember, they were things where you had the element symbol, and they could be surrounded by dots, up to 8 dots, depending on which group you were in the periodic table. So here we have our A group elements numbered: 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A, right? So remember, our dots correspond to that group number. So for example, an element in group 1, like lithium, for example, would have a single dot. So the dot diagram for lithium would look like this: one dot. If I did magnesium, the dot diagram for magnesium would have 2 dots. If I pick something from the 3A column, like boron, boron would have 3 dots. Okay, etc. So when I get up to sulfur, sulfur would have a total of 6 dots. And so we go 1, 2, 3, 4, go around again and start making pairs. And then when we get into this very last column, these elements have 8 dots. And so they're all going to be paired up. And remember, we said that these elements are not very reactive because they already have a full valence shell. We called that the Octet Rule. And the only exception to that was helium. So because helium's in this period 1, it only has that first energy level. Helium is actually full with just 2 dots, so we paired them up right away. That was the one major exception to our electron dot diagram rule. All right, so we're still reviewing, so you still don't have to write this down in your notes. Atoms are neutral. We've been talking about this for quite a while, and what this neutral word means exactly. So remember, atoms have the same number of positive protons in the nucleus and negative electrons out here in the electron cloud. So this element magnesium has 12 protons in the nucleus, but it also has 2, 4, 6, 8, 10, 11, 12 electrons in the electron cloud. Therefore, it is neutral. So something that is neutral is going to have the same number of protons. That means positive charge, right? And electrons. That's negative charge. Okay, so those positive charges and those negative charges, they cancel each other out and it becomes neutral. All right, today we're going to talk about what happens when an atom isn't neutral anymore. If an atom isn't neutral anymore, it becomes something called an ion. All right, so an ion is an atom that has lost or gained electrons. And now, because it doesn't have the same number of electrons and protons, it has either a positive or a negative charge. All right, so here we have an example, right? I've got the element sodium on this side. and it's losing an electron from its outside energy level. And that electron's going over here to chlorine. Okay, so now sodium doesn't have the same number of electrons and protons anymore. It lost a negative particle. So when it loses a negative particle, it becomes positive ion. All right, chlorine, it gains an extra negative particle and becomes negative. All right, so the other thing we have to remember is when ions form, it's only because electrons are moving. Protons can't move. They're stuck in the middle, okay? Electrons are on the outside, therefore they can move. Protons in the middle, they're trapped. All right, so how do we know if the atoms will react? We had a slide that looked like this before break, but again, we're doing a lot of review. That thing was called the Octet Rule. Now, I don't think we actually gave you the name for it. We told you what it was, but this week I'm giving you the name for this rule, okay? So this rule is called Octet Rule. And anytime you see that prefix oct, it means 8, right? Just like octopus has 8 arms, right? So octet has something to do with 8, means atoms will share, gain, or lose electrons in order to have a full outer energy level. All right, so look what's happening here with sodium. It has only 1 electron. When it loses it, now the new outer energy level is full. It was the one that was underneath. Okay, chlorine, on the other hand, I wish I could pause this. When it gains 1, it fills up the outer one. So now it has 8 as well. All right, so how do ionic bonds form? Well, when these ions are created, right? So now here's sodium. It gave this electron over here to chlorine, and now sodium became positive and chlorine became negative. All right, so when these bonds are forming, this ion formation process is happening, and it's a process of forming cations and anions. All right, and so you're going to have to rearrange these to put it in your notes, because in your notes I think it said cations are ... and you're going to have to describe what a cation is, okay? If an element is a metal, remember that's most of the periodic table, it's going to lose electrons. When that happens, it becomes a positive ion called a cation. Okay, so now think about how can you rearrange that into a statement that describes what a cation is. All right, for example, sodium is a metal. Sodium lost an electron. Sodium became positively charged. Therefore, sodium is a cation. All right, so let's look at the opposite. Nonmetals gain electrons. So not very much of the periodic table is nonmetals. That's just that right corner of the periodic table. All right, so if an element is gaining an electron, it becomes a negative ion because it's gaining a negative particle, and we call those anions. All right, so think about how you can describe this, starting with anions are. Okay, so here's chlorine. Chlorine gained an extra negative particle, so it became negatively charged, and we call it an anion. All right, and we can draw these ionic compounds showing these ionic bonds, and there's 3 simple steps. All right, the first step is draw the dot diagrams. Right? These are the things we already learned how to do. They have dots around them. Right? Up to 8. So as few as 1, as many as 8, depending on which column they're in. And then you're going to move the dot or the dots from the metal to the non-metal. Okay, so up here you should actually have 2 dot diagrams, right? Or however many for the elements that you have in your compound. That's why there's a plural here. Diagrams. There's going to be more than one. And then you're going to redraw everything once you've moved those electron dots over and include the charge numbers. So let me show you how that works. All right, so for this one, we're going to be doing magnesium and oxygen. All right, so in order to do the dot diagrams, we have to consult our periodic table. And we can see here that magnesium is in the second column. Okay, and oxygen is over here in column 16. That's the same thing as 6A. Okay, so magnesium is going to have 2 dots. Oxygen is going to have 6 dots. All right, so here's my magnesium. I'm going to put 2 dots on there. And now I've got my oxygen, which was in 6A, so I'm going to have 6 dots. All right, so step 1 done. Notice here that it says diagrams, dot diagrams. That is plural, right? Because you're going to have to do, if you have 2 elements, you're going to need 2 dot diagrams. You can have more than 2 elements in your compound, but we won't do any that big. All right, step 2 is move the dots from the metal to the non-metal. Well, let's grab our periodic table again. Okay, remember everything over here in all this blue all the way up to here, all this stuff is metals. And then this stuff over here is non-metals. The stuff in the green and the stuff in the pink are noble gases, okay? So if it is in the green here, these small number of elements, they're going to take electrons. And if it's anything else, it's going to give electrons. Okay, so just so happens that we always write our metal first. So magnesium is our metal. Oxygen is our non-metal. And this is kind of like a puzzle, right? Because we have 6 dots, but there's still room for 2 more dots. It's not quite full, right? And it just so happens we have 2 electron dots here. So we'll move this one here, and we'll move this one here. So magnesium is going to lose these. And then we're going to redraw it, showing these moved dots. All right, so now I have magnesium with no dots because they've been moved over here to the oxygen. And now look at the oxygen has 2, 4, 6, 8 electron dots. It has fulfilled the octet rule. It is now happy, just like a noble gas, okay? And the last step says to include the charge numbers here, right? So how much charge does each one have? Well, magnesium lost 2 negative particles. If you lose negativity, don't you become positive? I know if I get rid of my negativity, I become positive, right? Same is true for elements. So if you lose 2 electrons, you gain a 2+ positive charge. But if you gain negativity, if you gain negative particles, you're going to become negative, right? So just like if you get negative people in your life, you become kind of a negative person yourself, right? So elements are the same way. So the oxygen got 2 extra negative particles, so it's going to have a -2 charge, right? And so now we've drawn both of these ions. So this is actually a cation, right? Because it came from a metal. And this one over here is an anion because it came from a nonmetal. And then there's a special way that we can draw these in the very end, right? One last step here is I draw these dots inside of a bracket. Okay, and I put the charge outside. And then I put the next one really close. And these brackets tell the reader that these two elements are bonded together. Okay, that they are ions and they are bonded together. Okay, so this is the officially correct way to show an ionic bond. All right, we're going to do more of this practice on Thursday and Friday of this week. So I will see you all in our synchronous meeting on Thursday and Friday, and we will do some more of these. Bye-bye.